This is Mrs. Murphy here at Weber State University, and today we're going to go over the programming chapter in your textbook. We will discuss different programming languages and show some examples of interpreted versus compiled languages and high-level versus low-level programming languages. We'll also go over the structure of a program, including some of the control structures like if statements and looping structures, and also a little bit of object-oriented programming. A program is coded instructions to solve a problem. People will talk about apps that they put on their phones and their tablets and stuff. Well, an app is a type of a program. It's short for application. An app's also coded instructions. The difference is the interface. An app has a user interface that allows us as humans to use it. Now compare that to a program. Program could be for human use, but it doesn't necessarily have to be. It could be instructions for a robot or for a server, or even some types of computers for your car would have instructions and programs in them. When you write these instructions, you use code. Source code is just the program statements written in a programming language. Compare that to pseudocode. Pseudocode is just your program logic that's written in English. You can use pseudocode to help you think out your logic. With any coding, you have to figure out what method you're going to use to solve the problem. This is your algorithm, or the steps for problem solving. Remember Sheldon's friendship algorithm on how he made his friend? Now, I have a video link for you in the modules that's going to do a great job of explaining what algorithms are. Now, the computer doesn't actually read the code. It has to be converted into something the computer can actually understand. Most of the time, this is like an executable program that you'd put on your computer. Now, Java is kind of a special case. It doesn't create executable files. Instead, it gets converted into bytecode or executable jar files. Not sure if you ever looked when you're coding some of these Java programs. You compile them, and then you'll see some extra files in there that have the same exact name as your project. These are the class files, or the code that the computer can execute. Since the computer doesn't read the code, there's two ways that the computer can get to understand the code. You can use a compiler to convert the code, or you can use an interpreter to read the code to the computer. A compiled language is something that creates an executable. You write your source code, and then you compile your project. This will create object code, which is converted into an executable project, and then someone can run the executable program without the compiler or without even the original source code, and it will run and display their program. HTML is an example of an interpreted language. You wrote the code, and then you use the interpreter to view it. In our case, our browser was our interpreter. All we needed to do was view the code in the browser, and it understood what it was. Now, Java is kind of a unique situation. It kind of combines both the interpreter and the compiler. You write your source code, but then you compile it into bytecode or an executable jar. But then you can use that bytecode on any device, so long as it has the Java interpreter installed on the machine. Java and HTML are examples of high-level programming languages. The commands are similar, or more similar to English than computer commands. Low-level languages include machine language and assembly language. Assembly language is just a slight step above actual machine language. Commands are letter codes to match each of the machine language instructions. Now, machine language is the lowest level language that there is. The instructions are binary bit patterns. This is actually the only instructions that the computer can carry out. Here's an example of assembly language. I'm not sure if you remember back to the architecture chapter, the computer only understands certain commands. And these commands are things like move or store data. This example displays the message "Hello World" to the screen. Now, the book will go into more detail about some of the other assembly language commands. Now, compare that to a higher level language. At least in Java, you can understand the words system and print and stuff like that. The syntax of a programming language are the commands and the punctuation of that particular language. In a programming language, the basic operations you need are variables, operators, control structures, and objects. Now, we've already talked a little bit about variables and operators. So now we're going to show you a little bit more about control structures and objects. The four main types of control structures in a programming language include invocation, sequence, selection, and repetition. Invocation is writing code that's designed to be reusable. You can then call that code when you need to. We've already used this before in our My class code. There's a method for draw and key press and mouse press in the timer. The sections of code are called methods. Those methods are executed when that particular event is called. Sequence is when the flow of the program goes in order from top to bottom. You've probably noticed this when doing graphics. The commands are executed in order, so the most recent commands cover up any of the previous commands. Selection is when we control the flow of the program depending on a condition. Now, we've used if statements in each of our programs before to control the outcome of the program. In this example, the output would say, "You can vote," if the age is 18 or more. Otherwise, it would say, "Not old enough." So the flow is determined by the condition. Now here's an example that's going to combine selection and sequence. I have an if statement on the left side and an if-else statement on the right-hand side. Both examples use the same exact conditions where two variables are compared to the value 1. The example on the left uses a series of if statements. The example on the right uses an if-else structure. Now the difference in these series is the one on the left is sequence. In other words, it's going to check every single one of those conditions, and it's going to execute all of the statements for every single true statement or true condition. Now on the right hand side, on the if-else structure, it's going to hit the first true statement, and it's not even going to test any of the rest. Repetition is when the code repeats the series of statements. Now there's three types of loops in Java, or repetition in this case. First off, you have a for loop or a while loop. A for loop iterates a certain number of times, while a while loop iterates so long as a condition is true. Now we can break that down further and have a pre-test loop and a post-test loop. A pre-test loop just means it tests the condition before determining the iteration. A post-test loop means it's going to iterate through the statements and then test at the bottom. So now a for loop, which we talked about, is an example of a pre-test loop. It tests the condition before executing the statements. A while loop can be either pre-test or post-test loop. Here's an example of our for loop. If you look at the parentheses of the for loop, it's going to tell you the start, the condition, and the increment, and it's all separated by little semicolons. In this case, there's a variable called I in the start, and it's set to start at 2. You could change that number to any other value you wanted your for loop to start at. So start at 1, start at 0, whatever you want. Okay, now the condition, it determines how long the for loop is going to iterate. In this case, it's so long as I is less than or equal to 10. The increment is set up to a plus equals 2, so this particular for loop is counting up by 2's. So the value of I as it iterates through the loop is going to be 2, 4, 6, 8, 10. But the loop is going to iterate 5 times. So now here's an example of a while loop. It's going to iterate so long as a condition is true. In this case, the condition is while num is less than binary digit. So if that condition were true, the loop would execute until it weren't true anymore. Now suppose that binary digit were a negative number. Since num is set to 1, that would make it a false statement, since 1's not less than any negative number. In this case, the statements inside the brackets would never execute at all. So a pre-test while loop is very similar to an if statement. The statements might not execute if the condition is not true. And even the syntax, if you look closely at the syntax, it's exactly like an if statement. All you do is change the word while to if, or if to while, and you can interchange where they are. The difference is an if statement just executes the code once, while a while loop executes it continuously until the condition is false. A do while loop is just a while loop, but it's been turned upside down. Conditions at the bottom instead of at the top. Now, since there's nothing at the top preventing the statements from executing, remember how it goes, the statements always go in order? Well, since that's the case, a loop's going to iterate at least one time before testing the condition. So in this example, you have to roll the dice before you can test to see if you have snake eyes. So that's why a do-while loop is a good example for our little snake eyes test. If either of the variables for the dice are greater than 1, then you don't have snake eyes and the loop is going to continue to iterate until you do. So here's a pre-test and a post-test while loop side by side, so you can kind of get an idea of both of them. The condition is exactly the same on each of them. In this case, the condition is that the loop will iterate so long as the variable num is less than 10. These two loops will behave exactly the same and the output will be exactly the same. Now there's one time when these two loops would differ in their output, and that's if the variable num were already greater than 10 at the start of the loop. In that case, the pretest loop would never execute the statements at all, while the post-test loop would execute them at one time, and then it would test to see that it's false and it wouldn't repeat it. So to sum up loops, we got a for loop, a do-while loop, and a while loop. You use a for loop when you know the number of times you need your code to iterate. Now you use a do-while loop if you need it to run at least one time, such as our little dice example. You can't test to see if you have snake eyes unless you've actually rolled the dice. Any other time, you'd use a while loop. This brings us to objects. Objects are kind of an important part of programming. Rather than coding line by line and thinking of your logic that way and your flow, you're going to think of logical objects that would appear in the code. Once you have an object, you're going to think about, well, what properties does that object have, and what actions does that object have, and then you can code properties and actions. Okay, suppose we're doing some sort of game that involves a ball, or a little basketball app, or what have you. So here we have a ball object. That would be a logical object in our code. Now you can have properties for your ball, such as the diameter, the color, the brand of ball if you want it. Then you're going to have actions for that ball. What does that ball do? Does it bounce? Does it roll? You code the properties and actions in a class. A class is the blueprint for your object. It's going to define all the object's actions and behaviors. Now you can then reuse that same blueprint for multiple objects. Now an object is what gets created from the class. So let's take a house class. We can adjust properties of the house object, and you can end up with many different types of houses, such as you got the psycho house or the white house or whatever house you decide to dream up with your class. So the class is the blueprint to make the object. So now here I'm going to let you try and guess. Try and figure out which is the class and which is the object between planet and Earth. Did you get that? Since Earth is a type of planet, then planet would be the class or the blueprint, and Earth is the object or an instance of the class. Okay, let's try the next one. Corvette or car? Which is the class, which is the object? All right, since a Corvette is a type of a car, then car is the class, Corvette is an object or an instance of the class. Okay, here's a tricky one now. We've already actually used objects in our code. We used the random number generator. So, which is the class and which is the object between random and generator? Well, in our code, we always say random generator equals new random. Generator is the object of type random. So random is the class. When you code a class, the class variables are all the properties of the object. So going back to our ball class, diameter, color, those would all be class variables. The behaviors of the object are going to be the actions. So suppose we had some sort of pet or animal object. You can have an eat action or a kick action. Now this goes back to our invocation we talked about earlier. You code the kick or the eat or whatever behavior you want, and then you invoke or call it later when you need to use it in your code. Instantiating the object means you're going to actually create the object. You're going to use the keyword new. So given a shoe object, we can declare and instantiate the object by saying shoe clog equals new shoe. Suddenly our object exists. We can now use it. Now if you want, you can just declare the object. That means just give it a name. So here we have shoe flip-flops. But we can't use the object yet. It doesn't actually exist. That's why it's in the little thought bubble right there. We didn't use the keyword new yet. Then you can instantiate the object, and the little thought bubble goes away because now we've used the new operator, and the object now exists in our code. So objects are another way of just thinking about how to code your projects.